Okay, I think we'll go ahead and get started. So thank you everybody for joining us today to discuss the adapt stage of waves to water. I just wanted to kick things off. This is Jennifer Garson from the U.S. Department of Energy's Water Power Technologies Office. And we're really excited about this newest stage of our prize. We're excited to have the Coastal Studies Institute, who will be explaining sort of their role in the final stage of the prize. And we're really excited to see how you all will design your systems suitable for testing in 2022 at the Coastal Studies Institute. We recognize that we had to change some of the timeline and the stages of the prize, well, ultimately for determinations due to the current situation with COVID-19. However, we really view this as an exciting opportunity for our competitors to really think through the design and implementation of a system that could both function at the Coastal Studies Institute and really think about the long-term reliability, resiliency of these systems in the context of serving in sandy bottom environments. So we are thrilled to have all of you online, and we're really excited to tell you more about the adapt stage. And I want to encourage people to ask as many questions as possible, both to the WPTO, NREL, and CSI staff, and view this as a dialogue for this webinar. So with that, I'll hand it over to Jenny Weigel from NREL.
Thanks, Jen. Okay, I'm just going to walk you guys through some of the introductory information and some basic logistics for the webinar today. You're all joined in listen-only mode, so if you have any audio issues, just try to disconnect and reconnect just via your phone. And if that doesn't work, send us a quick chat and we'll troubleshoot with you. And then as Jen mentioned, if you could submit any questions that you have via the chat box, we will do our best to answer as many and as all of them as we can today. So we will cover a quick summary of the prize today, although I'm sure most of you are already familiar with the current structure. We'll then go into some of the new details of the adapt stage, the timeline, the submission requirements, and some of the new information on the test site, Jennette's Pier. And as Jen mentioned, we have a few members of the Coastal Studies Institute on the line today, and they'll share some information about the site before we open it up for questions to the group. And then you'll also find two handouts from CSI available in your GoToWebinar platform. And these will also be later available on HeroX for you to download as well. But please do use that information and take a look through it. And I'm sure CSI will give you a little bit more detail as we talk through that today. So just to kick us off, at a high level, the Waves to Water Prize is now a $3.3 million prize to develop small, modular, cost-competitive desalination systems powered by wave energy. The goal is to provide potable drinking water to remote and coastal communities and improve disaster response. The prize team is looking to achieve these goals with the submitted designs, the flexibility in varied wave conditions, the fact that they're easily deployed, they can ship in a standard shipping container, deliver a minimum water quality, and operate without environmental degradation. Previously 4 stages, the prize is now 5 stages and will run through April of 2022 with the aim to accelerate technology innovation in wave energy powered desalination systems. We're aiming to provide a pathway from initial concept through to open water testing, and the new timeline here with the new 3rd stage, adapt stage, is incorporated. So far, we've awarded $10,000 to 20 winners in the concept stage and $47,000 to 17 winners in the design stage. Competitors in the adapt stage will have 180 days to document a thorough and robust design of a system specific to testing at Jennette's Pier. The design must also be able to be scaled for similar environments for disaster relief or remote community water access. This design will be accomplished through a combination of thorough engineering analysis, design drawings and documentation, and developing a plan to build their technology in the create stage. Teams that demonstrate the technical capability and detailed plans to build a functional or proof of concept prototype will be awarded a cash prize and invited to compete in the create stage. Any eligible entity may compete in the adapt stage now, regardless of previous participation in concept or design, but this is the last opportunity where new innovators will have the opportunity to participate in the prize. We provided some additional information and an update on the timeline in this iteration of the rules. So looking ahead, in the create stage, winners of the adapt stage will have 180 days to provide evidence of a viable system and develop a plan to finalize and deliver their technology for the drink stage. This should be done through physical builds and tests of critical or novel components and subsystems. Between 5 and 10 winners will be awarded equally from a total prize pool of up to $500,000, but not to exceed $150,000 each, even if less than 4 winners are selected. Only winners of the adapt stage can compete in the create stage. Winners of the Create stage will have up to 180 days to build and ship their systems to Jennette Pier in Nags Head, North Carolina, and you'll have the opportunity to ask questions of the Coastal Studies Institute today to better understand the environment. Competitors will compete on efficiency, logistics, and system integration metrics, and will be scored on the ability to meet minimum thresholds and how they performed against defined metrics. Only winners of the Create stage can compete in the Drink stage. There will be multiple winners selected from the Drink stage, including one grand prize winner representing the best overall score, determined based on a combination of water quality and volume produced during the 5-day test period. This relationship of quality and volume produced through the wave-powered desalination system represents the energy use of typical reverse osmosis systems. A formula has been developed to calculate the score to determine which team best manages the trade-off between these two metrics and is included in the rules document. Individual metrics prizes will also be awarded to competitors in other categories for a total prize pool of $500,000. Metrics prizes will include winners for the cleanest water, the lowest weight, the most water, and the simplest assembly and deployment. The director of the Water Power Technologies Office is the judge of the competition and will make the final determination on winners to receive these and all of the awards throughout the prize. As always, you can find the most up-to-date information in the rules document available on the URL that's shown here, and you can also find it when going to the Resources tab on the Waves to Water HeroX page. We'll also provide additional resources here, including the new test site details document, and that'll include the information on Jennette's Pier here as well. The timeline for the ADAPT stage with the opening on June 8th, and we'll accept applications through November 30th. We're anticipating an announcement of the ADAPT stage winners in December of this year. The list here includes all of the required submission documentation for the ADAPT stage. Unscored items include a cover page, a submission summary slide, and a test site detail table. The test site detail table must provide information on how your system will function, including required connections at the Drink stage. See the rules document for a full description of the expectations for each of these submission package items. There are 3 scored elements in this stage, including a 2-minute video, a technical narrative, and modeling documentation. In the chart here, we've broken down the weighting for each of these scored categories. The 2-minute video must explain how the system will function at Jennette's Pier and why the system is suitable for a variety of sites with similar conditions. There are 3 statements used to evaluate the video. The technical narrative is a technical document that demonstrates the feasibility of the system and how the system functions and a plan for how the system will be prototyped in the Create stage. It'll also define how it will be tested in the Drink stage. There are 27 statements that will be used to evaluate the technical narrative, and you can see the individual criteria here. The modeling documentation will show the modeled results of the proposed system, including populating the 2 mandatory tables to explain the anticipated water production and energy production during the 5-day test period. There are 4 statements that are used to evaluate the modeling documentation. Here's some additional information on the 2-minute video submission. This will be publicly accessible again, so keep it in mind when developing the content and determining how the video will be shared with the reviewers. The reviewers will score the video based on the content you've provided, not the quality of the video itself. This format should explain the operating principles of your system, including the design of your system and how it will function at the Drink stage at Jennette's Pier, and how you will progress building your prototype in the Create stage. The technical narrative will be evaluated against 4 criteria, and you can use up to 7,500 words and up to 15 supporting images, figures, or graphs to populate the template provided on HeroX. The 4 criteria are the robust design and analysis, how will your system meet the prize requirements, and what analysis supports your design. The second criteria is system build and deployment feasibility. Do you demonstrate that off-the-shelf components of your system have been identified and/or purchased? And for novel system components, have you demonstrated adequate design and detail of your system? Third, your plan. What is your plan to achieve your goals? And fourth, the scalability and performance beyond the price. Does your proposed solution have additional attributes or produce other benefits that would be valuable beyond the price? To describe your modeling methodologies and findings underpinning your response to the technical narrative, you can use up to 2,500 words and up to 10 supporting images, figures, and graphs in the template provided on HeroX. The 2,500 words are limited to the findings and methodologies from the modeling efforts. The water production results table and the wave energy converter modeling results table must be filled out in your submission, or the submission will be deemed ineligible. Your submission will be evaluated against the review criteria that are listed here, and more detail is provided in the rules document. And here's a summary of the minimum system technical requirements. This has not changed from the previous versions of the rules, but we wanted to make sure to highlight this so that the group understands the overall goals of the prize and how what you're working on connects to your system. Further details on this can be found in the rules document. New to the ADAPT stage is the test site detail table. This is not a scored element of the competition, but is a required submission to help the organizing team obtain the necessary equipment to prepare for the drink stage. Competitors are asked to complete the table included in the rules document that includes your plan for deployment, mooring or anchoring, electrical connections, water delivery connections, and NEPA clearance. Further information on the technical details for the test site are included in the drink stage test site resource document that's available on HeroX, and some of the partners from the Coastal Studies Institute are on the line today to share some of those details with you directly. And with that, I will hand it off to Simon Gore.
Hello, this is Simon Gore from the U.S. Department of Energy. Just want to clarify a few things in this ADAPT stage, and these are basically what we're calling key points of emphasis. So one is that we want to understand a feasible path to deployment and a process to de-risk solutions. So one thing we want to see in the ADAPT stage that would be a path through create and drink that really shows us that you're thinking about how this will be deployed and how you're de-risking your solution. Secondly, someone can score quite well on this and be awarded prize money theoretically, but we also want to evaluate the feasibility of claims made in either the technical narrative or modeling documentation. So we just want to emphasize that the score alone won't necessarily get you through to the create or drink stages. And then finally, when we're considering the technical narrative, modeling documentation, and the minimum requirements table, since we're now providing an actual test site at Jennette's Pier, any design evolutions or changes made from the previous stages should be reflected in those pieces of the documentation as part of your submission for this stage. With that, I'll hand this over to George Bonner and our partners at Jennette's Pier, CSI, and the North Carolina Renewable Ocean Energy.
Hey, thanks, Simon. So like you mentioned, I'm George Bonner, Director of the North Carolina Renewable Ocean Energy Program. I'm based at the Coastal Studies Institute here on the Outer Banks. And first, we're really looking forward to hosting the drink phase, and we're excited to be part of the competition. And I'm really looking forward to seeing the pioneering work that you guys are working on. And I really do think this is game-changing work. And we've got a short video to just introduce our team and a little bit more about Jennette's Pier, where the drink phase testing will happen. So we'll go ahead and play the video now.
The Coastal Studies Institute is a multi-institutional research and education partnership led by East Carolina University in collaboration with NC State University, UNC Chapel Hill, UNC Wilmington, and Elizabeth City State University. CSI's interdisciplinary research focuses on pressing coastal issues, including renewable ocean energy development. For almost a decade, the state-funded North Carolina Renewable Ocean Energy Program, a collaboration between CSI and the Colleges of Engineering at NC State University, UNC Charlotte, and NCA&T University, have been researching and developing new ways to bring ocean energy technologies to market sustainably, while working with private industry to test devices in the waters off the Outer Banks. CSI operates a renewable energy testing site in partnership with Jennette's Pier, a North Carolina Aquarium's operated facility located in Nags Head, North Carolina. The research experience, technical expertise, and infrastructure available for deployment and testing make CSI and Jennette's Pier an optimal location and partnership for teams in the drink stage of the Waves to Water Prize.
Hi, I'm George Bonner, Director of the North Carolina Renewable Ocean Energy Program, based at the Coastal Studies Institute. On behalf of our program, I want to congratulate each one of the teams on your pioneering work and your success in the Waves to Water competition up to this point. The North Carolina Renewable Ocean Energy Program is focused on advancing technologies to harness the power of our waves, our currents, and our tides to provide clean energy solutions and to also power our blue economy. We collaborate across the UNC system schools, including North Carolina State University, UNC Charlotte, North Carolina A&T, and the Coastal Studies Institute. We're really excited about hosting the drink phase of the Waves to Water competition here on the Outer Banks and look forward to working with each one of your teams. In partnership with Jennette's Pier, we have a great group of folks here to help support the competition. We're focused on 3 areas. First, making sure we provide a safe environment for the testing. Number 2, we want to protect our environmental resources here on the Outer Banks. And then third, we want to maximize fairness throughout the competition and provide opportunities for your teams to succeed.
The drink stage of the Waves to Water Prize will be held at Jennette's Pier, a state-of-the-art education and research pier located in Nags Head on North Carolina's Outer Banks. Operated by the North Carolina Aquariums, the 1,000-foot-long pier has the infrastructure and staff expertise needed to successfully host the Wave to Water Prize. In addition, with annual visitation of over 250,000 visitors, Jennette's Pier will provide significant public exposure and outreach for the drink stage of the prize.
My name is Mike Remage, and I'm the director of Jennette's Pier. I think you'll find that the pier is the ideal location for the Waves to Water Prize drink stage based on our marine environmental conditions, ample infrastructure, and past experience working closely with the Coastal Studies Institute on ocean observing projects and ocean energy device deployments. When you arrive, your teams will have access to parking lot workspace to uncrate and assemble your device. Out at the end of our 1,000-foot-long pier, spider cranes will be available to deploy your device to one of the adjacent nearshore test berths. The Research Operations Building is specially outfitted with a trap door and a winch and basket system that allows researchers and divers access to the water if needed. Each team will have a station at the end of the pier from which they can monitor their device, collect their water, and interact with the public. The teams will be able to access the facility from 6:30 a.m. to 9 p.m. daily during the course of the event. Ocean View Hall, our 3,500 square foot reception room in the pier house, has been reserved as a base of operations for the entirety of the competition. Good luck, and I look forward to seeing you in 2022.
North Carolina's Outer Banks are well known for its dynamic ocean conditions and wave climate. CSI researchers and federal and state partners have robust data sets on wave climate and conditions that will be available to Waves to Water drink stage competitors.
Hi, I'm Mike Muley, Assistant Director of our North Carolina Renewable Ocean Energy Program and an oceanographer with several years of experience making ocean observations. I'd like to provide some background on the available ocean and meteorological observations to the Waves to Water competitors. All of the web addresses for these data will be provided to competitors in a separate document. There are historical wave measurements from a moored acoustic wave and current meter at the offshore 11-meter deep test berth. There are real-time and historical full directional wave measurements from our wave rider buoy located approximately 10 miles offshore of Jennette's at the 26-meter isobath. We have real-time and historical meteorological measurements from the end of the pier through a partnership with Weather Flow Incorporated. And we intend to deploy a spotter buoy at the Waves to Water test site soon that will provide directional wave spectra and surface water temperatures. We will make that real-time link available as soon as it is deployed. There are also several oceanographic and meteorological observations available from the Army Corps of Engineers Field Research Facility north of Jennette's Pier in Duck.
The Coastal Studies Institute will provide diving and vessel support for the drink stage of the Waves to Water Prize during deployment and recovery of wave energy devices. CSI vessels, ranging from small beach launchable inflatables to larger outboard vessels for diver deployments, and a 42-foot research vessel outfitted with an A-frame and a 2,000 capacity winch for deployment and retrieval. In addition to ensuring the safety and fairness of the Waves to Water Prize, CSI, Jennette's Pier, and DOE's National Renewable Energy Laboratories are dedicated to protecting the coastal resources and ecosystems of North Carolina's Outer Banks. Teams will be required to comply with competition rules, as well as state and federal laws designed to safeguard our coastal systems.
Hello, my name is Lindsay Dubbs. I'm the Associate Director of the North Carolina Renewable Ocean Energy Program. I also lead environmental and permitting aspects of our program. For the Waves to Water Prize, I will be working with competitors to understand the specifics of individual wave device and desalination systems that may affect the environment and ecology at Jennette's Pier, and to minimize any risks posed to elements of our environment. We will request that you provide information about the dimensions and weights of your devices, as well as their orientation and position in the water column and movement relative to the predominant wave direction. We also require that you share with us information about any fluids or lubricants that will be required for your system, mooring and waterline configurations, and anticipated emissions of light and noise. We will also collect information about brine discharges. Finally, we will ask that you have plans for full recovery of your systems from the test site at the end of the testing period. Colleagues at DOE, NREL, and I are beginning to collect this information from competitors now to allow us to begin the National Environmental Protection Act, or NEPA process. NEPA requires federal agencies to integrate environmental values into their decision-making processes by considering the potential environmental impacts of their proposed actions. NEPA clearance will be required prior to testing of the wave power desalination systems at Jennette's Pier. We expect that consideration of these environmental implications of wave power desalination systems will not only be useful for ensuring that we are good stewards of the environment around Jennette's Pier during the Waves to Water competition, but also to developers as they continue to pursue marine hydrokinetic energy solutions to coastal challenges at different locations in the future.
The drink stage of the Waves to Water Prize offers significant potential for outreach and public engagement in the area of renewable ocean energy development. The project team is planning a variety of events for the general public, both on-site at Jennette's as well as live streamed to the web. In addition, there will be opportunities to engage the next generation of scientists and engineers through programming provided for K-12 students and teachers during the competition. CSI, Jennette's Pier, and DOE's National Renewable Energy Laboratories are excited to be hosting this final stage of the competition on North Carolina's Outer Banks. The research experience, technical expertise, outreach potential, and infrastructure available make Jennette's Pier an ideal location for the drink stage of the Waves to Water Prize. Congratulations to all of you for making it this far. See you in the spring of 2022.
That's great. Thanks, everybody. And then I just wanted to open it up for questions here. So please do submit any questions that you have to the questions pane that's available in the GoToWebinar platform, and we'll be happy to answer anything that you guys have. The first question that we've received here is about the available anchor system. Is there an image available to show what this looks like and give some technical details behind what that available anchor system is?
So this is Mike at the Coastal Studies Institute. I'll be happy to take that question. At this time, we don't have an image available, but we certainly can make that available on HeroX and demonstrate what's being considered as an anchoring device.
Sorry, Jenny, can you see the questions? Because there are a whole bunch that have come in. I just want to make sure that we address them. Okay, I'll read them off. So one of the questions that came in is whether or not, and Lindsay, this would probably go to you, if we can share any information on brine discharge requirements at Jennette's.
I don't, I can absolutely share information about what discharge amounts are allowed in North Carolina waters. I'm happy to share that on HeroX.
The next question that we got in is how far from the pier will the competitors be allowed to go? So to the CSI team, there is a certain test berth area and competitors will be staged in that test berth area. But the key question is just how far from the pier?
So in the document about Jennette's Pier, it does provide guidance about this. So the area is from about 50 meters to 100 meters from the pier, from kind of the surf zone out to the end of the pier. So north and south, as I said, 50 meters from the pier to about 100 meters from the pier. Does that answer the question?
Yeah, and the next question was how close to shore?
So it is probably about 100 meters from shore to the end of the pier. And Mike Remage, if you can weigh in, I forget exactly how long the pier is.
Yes, you're correct, Lindsay. The pier is 1,000 feet long from the east side of the pier house to the end of the pier. So about the test berth area is about 900 meters from shore.
Okay, thank you.
Excuse me.
Next question is, oh,
Yeah. Sorry.
That's okay. The next question is, can the anchor supply lift off the seabed?
I guess they could lift off the seabed, but we would like for them not to lift off the seabed. And so that is why there were, I think we provided or will be providing information about how much force they can sustain.
That's correct. And also, just for competitors, we'll be putting out a matrix within the test area of chain pile anchors, and the chain piles are large chain links that are bundled together. And so there is not intent for them to be able to lift individual links.
Then the next question is, will the teams be allowed to choose their specific deployment spot at the pier? That is, can we know the water depth ahead of time?
The depth of the water through that entire deployment area doesn't change very much as you move from west to east. But so we can provide some information generally about the water depth, but the depth of the water changes because it is a sandy bottom environment. So it is very dynamic.
And then the next question is the depth and tidal range specific in the rules correct? 3.6 to 6 meter depth, which just goes to your question, the same question before, Lindsay, but it's a very high ratio tidal range to depth, meaning almost 1 to 1. Is it possible to move to deeper water? And the answer, given that the test site is no.
The only thing I would add to that is that in the observations link, we've given what we think will be the most accurate tidal predictions so that you can see the tidal variability during the month of April. That's all.
Can the water be collected at the device, or does it have to be pumped to shore? It will have to be pumped to shore. Question, which we might need some more clarification on, although maybe Scott, you jump in. Our device can benefit from advanced wave information. Can this be made available, or should we make provision ourselves?
Can you repeat that, Jennifer?
Yeah, so the question is, our device can benefit from advanced wave information. Can this be made available, or should we make provision ourselves? I think you might be asking for more detailed information about the wave conditions at the site. As was mentioned by Mike, there'll be ample information about historical observations provided, but perhaps if the questioner can kind of clarify what they mean by advanced wave information, then we can see if we can provide that information or not.
Yeah, and it sounds like, if I'm understanding correctly, I think the question is aimed at real time feed forward type controls, and in that case, no, we will not be supplying wave information from, say, 100 meters or a kilometer out for control strategies. As far as will you be able to make those measurements yourself, I think that's going to be dependent upon the particular plan and so on. But that, I think the short answer to that is likely to be no.
Yeah, the only thing I would add to that is that if you look at the Jennette's data document that's attached as a handout here, it provides links to some of the wave data that are available, and the offshore wave rider buoy does provide near real-time wave information to the public and to the competitors, and that will be available before and during the competition.
The next question is, can the device be deployed from the beach instead of using cranes from the pier? I guess answering from a WPTO perspective, that's one of the reasons why we're trying to better understand in this adapt stage what the deployment strategy might look like. It's a point of conversation that we've had with the Coastal Studies Institute and with our team. deems that it might be feasible. So if you believe that the best deployment strategy deviates from the spider crane, please make sure to detail that in your submission. In the rules doc, it says 1-point anchoring system. Does it mean that the device cannot be fixed to the seabed and that it must be floating? Hey, Scott, if you want to take that one.
I mean, I think the statement there, as Mike pointed out, be supplying a lump chain, mass anchor, if you will, with a standard shackle on it. So essentially, however you attach, whatever you are able to connect to that is in a fixed fair game. So whether that means it's floating or some other combination, that's if it deviates from that specific anchor point, then that's something that will have to be discussed with Mike and team at CSI to understand how that would actually be implemented and installed.
Yeah, and the only thing I would add to that is that some devices with like flat foundations, there is a significant concern of sedimentation during testing, and it won't be looked favorably upon if it's something that we don't think that we'll be able to remove from the seabed after the device test. So we're aware of the challenge of having something on the bottom that can be sedimented in and not removed after the competition.
The next question is, in the earlier document, the rules document, we were allowed to use some rock as ballast and anchoring. Can we use sand available at the pier as ballast?
The permit that we have does not really allow for, I guess that the sand can be removed if it's returned to the same exact location, but that is definitely something that I would want to just review and discuss with the developer.
And maybe just a quick note on top of that is that is part of the reason that we have added in the ability, the standard anchor connection points was to recognizing that we had originally thought about using local materials, but recognizing from a permitting perspective that may not be a realistic solution at this location.
Will we, the competitors, be able to assist in diving operations at Jennette's for deployment?
No, because of our diving certifications and requirements, we're not able to dive with any of the competitors. We have to dive within our certified American Association of Underwater Scientists for diving team.
Next question, the number of images in the technical narrative is limited to show the different systems of the machine. Technical drawings are not suited for in-report publishing. Is it possible to have a different submission for the numerous technical drawings? We really encourage you to stay within the limit and the number that we provided, and try to make sure that you adequately document given the number of images that you can use. It says the depth varies from 3.6 to 5 meters at the pier. Can the developer choose the exact depth of deployment?
I think that depth variability isn't necessarily a variability of location, along it within the test area. It's more like, as I said, this is a very dynamic environment with the sands shifting on and off shore, and we will definitely work with people to try and situate them in locations that will be suitable for their devices to be successful, but we can't ensure that we're going to have exact depths within that range within the testing deployment area.
Next question is, can we run electrical wires from the test berth to the pier? Scott, do you want to jump in, or I can answer that?
Yeah, I can. Yeah, so I guess with the intent, if this, I imagine this is aimed at systems that are designed, they're intended to produce electricity and potentially run a system on the pier. If we are working with the CSI team to understand if we should or make sense to standardize potential cables for running electrical units. If it's something that's more along the lines of running cables for instrumentation or something that's on the device, I think that'll have to be something that we work with the CSI team from an understanding of installation and other practices.
Does the anchoring cable have to be included in the competitor's standard container, or will it be provided by the pier?
This will have to be included in the container.
The next question is, can we operate right on the shoreline? And the answer is no. Can the supplied anchor be augmented with additional anchoring?
Yes, we would want to be in close communication with developers, but that is a possibility.
Yeah, and I would just add that the key concern with doing so will be whether we are confident that we can remove the anchor after the test.
But this is one of the reasons why in even the test site details requirement table, we ask for any additional mooring or anchoring systems that might be required, because we're trying to get a better sense of single point versus if we need to have some sort of staggered additional mooring. So please make sure to detail the additional anchoring that you might anticipate for your device. A question says, if the anchor provided is not needed for the mooring, can it be incorporated into the design of the system?
I think as long as the as long as this the standard connection points are utilized and there's nothing modifying that system. And I think back to Mike's point, if there's other mooring systems, it's going to be a question of can they be removed, and so that whole system would have to be run by the CSI team for approval before going through. But I guess in theory, I don't see why it couldn't, but it would need to be reviewed by the CSI team.
What's the typical wavelength?
It's probably in the 50 to 75 meter range. Is that fair, Mike?
Yeah, and I think the competitors will find that the observations that are provided to them can answer that question.
Yeah, similarly, there's a question about tides, and again, we would refer to the historical observations. Another question about whether or not if a concept requires 2 or more anchorings, can this be accommodated? Like we've said, just please make sure you detail what that anchoring system would look like so that we can determine whether or not it's either feasible, and if it were to move forward, any additional anchoring or mooring would have to be cleared by CSI, NREL, and WPTO moving forward for permitting purposes. Will there be any assistance there to help set up the device, or do we have to bring all of our own help? Your team will have to assemble the device. The deployment will be assisted by the Coastal Studies Institute. Is the pipeline for pumping water to shore provided?
We do anticipate providing some kind of a hose or pipe connection point for teams to deliver water from their test location to the pier.
Yeah, and the question right below that was whether or not water has to be pumped to shore. To be clear, the water will be pumped to the pier, which is where the collection devices will be assembled. Okay, so the clarification for advanced wave information was whether or not a competitor can deploy their own spotter buoy up wave for control purposes. Or Mike, would your Waverider buoy be able to provide real-time information for controls? I use it up wave at the deployment location.
So we anticipate that we'll have a spotter buoy on site that's available to all the competitors. And whether a team can provide their own spotter buoy for their own use is something that I think we need to discuss internally before answering that question.
The next question was if the deployment without cranes reduces the risk, is this acceptable? Like you mentioned, if you have alternative methods for deployment that is not with the crane via the pier, please make sure to detail them in your application. Next question is, will any additional anchor need to be provided in the container? And the answer is yes. Should you have it accepted as a deployment measure for your device, it will have to be within your container. Somebody asked a question about electricity to run an RO system, and as mentioned, we're trying to get an understanding of what type of cable would be needed to go from your device to shore. So please make sure to detail that in your submission.
And actually, I would add to that, specifically on that detail, as much detail as possible. One thing that we're trying to coordinate is, there's a number of different ways to power that, right? So you can imagine anything from a 12 volt DC to 110 AC and so on. So trying to get that standardized in a way that makes it doable for this contest. So if anybody is intending to run an off-the-shelf desalinator, please provide specifications on power requirements and voltage requirements as well. Especially because that'll actually also be necessary for us when we're dealing with NEPA permits and so on. So the more information we have, the better off we are.
A direct question is whether or not a device can rest on the seabed.
Again, as Mike has said, as long as we think that we will be able to remove the device eventually, that it could rest on the seabed.
There's a note that some systems may not need that anchor, so providing the weight of this anchor free will advantage some devices over others. And how will this be assessed in the judging? The removal of that weight from the container, while we're trying to make it easier for competitors in terms of evaluation of how your device will perform, it still all depends on how much water you're able to produce. But we're trying to make sure that it's accessible to everybody as a way to better facilitate a test at the end of this competition. So I don't know if you want to add anything else.
Yeah, the only thing I would add is specifically that 680 kilogram weight limit. That actually, just for reference, that is the maximum limit of the container that we'll be providing for this. It's not necessarily the anchor or anything like that. So it was more of everything, your system must fit in that container, and there is a specific weight limit attached to that. But yeah, as Jen pointed out, the intent here is to provide opportunities for contestants to cut out some of those anchor requirements. If there are necessary other anchors, we can, again, working with the team to do that. But the overall contest will be, as Jenny pointed out in the early slides, the winner of the contest will be based on water production and water quality. There are other potential purses available for things like weight and so on. So it's just a matter of each team will have to determine what compromises they're willing to make for each system.
Can you supply information on the horizontal load capacity of the anchors? For example, to check the design safety under angled mooring lines.
Mike, if you'd have any information on that.
So the question was the load capacity under angled mooring lines?
Yeah, it's the supply information on the horizontal load capacity of the anchors. And the specific example was to check on the design safety under angled mooring lines.
Yeah, we can provide estimates.
Someone noted that a standard electrical connection to the pier for the wave energy device is a very important element in our team's design. And so when will be decision made on this? That's why we're trying to understand what the electrical connections are that are critical for your technologies before we had a simple standardization.
Yeah, and just to clarify, the decision has been made that is allowable. It just hasn't been standardized on what that connection will be.
Will the water collection be located up on the pier or at sea level? So the question, do we need to generate the pressure and head to pump the water up to the pier level?
Yes, it will be on the pier, and it's about, just as Mike pointed out in the documentation, it's about 26 feet, depending on tide, above the water line.
Is it possible to put the water container in the ocean and collect it periodically? No. Will there be a scoring advantage to devices that require little or no CSI assistance with installation?
Well, given the permits and the safety requirements, CSI will have to do the installation. So there will be no scenario where CSI will not be installing.
However, to note, simple deployment measures as well as device assembly, that's one of the reasons why we have other categories for other prizes, even at the grand prize stage of ease of assembly and installation, given that that would be ultimately something that we would want to incentivize for these types of devices to be deployed for either disaster recovery or remote communities. What's the lifting capacity of the spider cranes?
So that's not an easy answer because it depends on the size of the device, the height that it needs to be lifted, the distance that it needs to be projected from the pier. And so there's a spec sheet for those spider cranes that we either have or can make available to competitors.
What is it meant by, quote, be scaled for similar environments? Simon, if you want to take that question.
Yeah, can you repeat that?
What is it meant by saying that that systems should be, quote, be scaled for similar environments? And this is one of the rule statements.
Yeah, I mean, we're looking at, we're selecting Jennette's because we see it as a representative site across many areas of the United States or other areas where these devices could be deployed. So when we mean scaled in the fact is that this is just one test model that can be replicable.
If the water pipe is supplied by CSI, what would the pressure rating be?
This hasn't been determined yet. We're still working on some details here, but the pressure rating of this will be relatively low. So this is not intended to be a pipe that can handle the full pressure rating of an RO system. Therefore, if you are pumping water to shore, it's going to have to be kicked up likely at the pier. So whether that be, whether again hasn't been determined, but likely under 100 psi rating is likely for that hose.
There's another question about the design drawings and photograph of the anchors. As Mike mentioned, we'll get something up on HeroX to show you a representation. Will lifting straps be provided for the spider crane?
I think the lifting straps are something that we'll provide just to assure that we have everyone's safety considered.
And maybe follow on to that, as teams are thinking about that, with ensuring that there are lifting points for your device would be preferred.
Does scaled mean the ability to be different sizes for different sites? I mean, absolutely, that's a consideration whether you are thinking about modular systems or how your device might scale, but that's scaled either in terms of, sizing or number of devices, yes. Says, is it possible to put the wave energy converter in the ocean, but the RO module on the pier? And yes, it is. The rules doc says that the shackle will be 60 centimeters from the sea floor. Can you describe why this is? Will it be rigid, or will the shackle attachment point move vertically or horizontally under load? Mike, I think that's a question for you.
Can you repeat that, Jennifer?
Yep. The rules doc says that the shackle will be 60 centimeters from the sea floor. Can you describe why this is? And will it be rigid, or will the shackle attachment point move vertically or horizontally under load?
I think the consideration was that there'd be a standardized chain that goes from the chain pile to an attachment point shackle, just to keep things from being buried, so that we can work with them. So if we put all the chains out ahead of time, the anchors, as we will, then we would have like a subsurface float with that shackle on there to assure that it doesn't get buried in the time between our deploying them and the competitors coming on site. So it'll likely be a length of chain to the shackle that's floating subsurface underwater, and it will not be rigid.
If we put the RO module on the pier, can we adjust or maintain it during the 5-day testing?
So currently, right now, we're anticipating that once the system is up and running, that you will not have the ability to tweak or maintain systems. However, that may alter as time goes on, but at least at this point, the intent is, the short answer to that will be no.
Can you provide a description of the proposed anchor point? It sounds like it'll be a clump weight consisting of chain with mass in water of 680 kilos. Like we mentioned, we'll provide some more information, including any drawings or renderings to help better describe what the anchoring system will be. Looks like for now, those are all of the questions that have come in. We're right at the top of the hour. If you have any additional questions on the site, oh, one more question. If we want a rigid anchor attachment, can we replace the chain mentioned with a rigid components?
I think that's something that we'll need to discuss internally as a team to answer.
I'll make sure to provide an answer up on the HeroX Q&A. I'm not sure I understand one of these. Another question, the anchor weight is directly related to the ability of some devices to capture wave energy. So providing this provides an advantage for some devices to produce water. How will this be addressed in the judging? We understand that it might bias towards, systems that do rely on that. For this is a prize. This is one of the design considerations that we determine internally. But Scott, I don't know if you want to provide any additional information.
No, I think you covered that, Jen.
Last question, if it is a length of chain, then can part of this be lifted off the seabed?
So to avoid that, it's not just a length of chain with an attachment point at the bitter end. It's actually a bundled pile of chain that we put down. So it's certainly not rigid, but it's not like you're lifting part of the chain anchor all the time. And I think that'll be apparent when we provide some visuals of the proposed anchor system.
I think now that might have been the last question. If there are any other questions, I encourage you to submit them either to our Waves to Water inbox or post them on the forum. We monitor both constantly to make sure that we're addressing any questions. But I think given that we're at time, I want to thank the CSI team and Jennette's Pier for joining us today, and thank our lab staff and all of you also for joining. We're really excited to see what these systems look like. We're excited for the competition to continue, and we appreciate everybody's kind of flexibility and understanding that we're trying to make sure that this is the best competition possible. And we're excited for April of 2022.
Yep, and maybe just that last question came in from Mark. Yes, it is 2022. We have pushed the prize back an additional year.
Please make sure to look at the timeline.